Hello, Integrated Math 1. Welcome to lesson 2.1.2b. We're on day 2 of making sense of different representations of a linear function. So we've already talked about our goals before, but just to remind ourselves a little bit, we're going to determine whether a scenario, equation, table, or graph represents a linear relationship. We did that last time, right? Good times. We're going to calculate the average rate of change from a table. We also were working on that last time. Hooray for us, because average rate of change is just another word for slope. We started looking at writing functions given a table of values. We're going to play with that a bit more. And interpreting expressions that represent different quantities in terms of context, a graph. What are these things? What do they mean? And compare different equation representations of linear functions because there are different ways to write our equations for linear functions. So our key terms, polynomial, degree, leading coefficient, zero of a function. We'll be getting into some of those in the coming bits here. So you know how to determine whether a relationship represents a linear function, right? We've been doing pretty well with these. You know how to write an equation for the function. If you have a slope and a y-intercept. Or we know we can write it as an arithmetic explicit formula and turn it into a function. That works too. So how can you use the structure of that equation to identify the characteristics of your function? So this is great. It's a y-intercept, it's a slope. Great. What does it mean, though, in terms of our situation? And how can we use that? So to kick us off here, we're on page M2-27. Marilyn sells silk-screened t-shirts for her mom at local festivals. After each festival, she returns whatever money she earns to her mom. Good job, Marilyn. The graph shown represents her potential earnings based on the number of t-shirts she sells. So you have this lovely graph here on page M2-27. So can you just take a moment to analyze and interpret the graph? Remember that our x-axis is our number of t-shirts, our y-axis is our potential earnings in dollars, how much money she's making off of it. So can you list as many facts as you can about the scenario based on what you see on the graph? So here you have a graph and we know it's describing Marilyn selling t-shirts. Can you just tell me what you can figure out about that from the graph, how it relates to the scenario? Go ahead and hit pause, jot down some things you notice, and hit play when you're ready to check it. So there are some hints off to the side over here of things you might want to ask yourself, right? What is the meaning of the slope? What is the meaning of the x-intercept, the y-intercept, maybe even domain and range, right? Things you want to ask yourself. So the first thing I noticed was 0, 0. That's both my x-intercept and my y-intercept. And I was like, okay, well that means Marilyn makes $0 for 0 t-shirts sold. I felt like that was fair. But then I take it a little further and I was like, well, but if I go to 4 t-shirts, it looks like she makes $60 when she sells 4 t-shirts. Just because I can see, in fact, let me use my pen here. So I can see 0 t-shirts, $0 for 0 t-shirts sold. But then I saw another point here where if she sells 4 t-shirts, she makes $60. So I thought, okay, well, if it's $60 for 4 t-shirts, then it sounds to me like I can just do a little bit of slope, right? Rise over run. So I rose 60, because again, slope should be helping me here. I ran 4. And I grabbed my calculator and I was like, okay, well 60 divided by 4 is 15. My slope is 15. 15 what, you ask? $15 per t-shirt. Right? My rise is in dollars, my run is in t-shirts. So Marilyn's making $15 per t-shirt she sells. So the slope actually does tell us something about Marilyn's situation, right? It tells us that she's making $15 per t-shirt. We kind of already did this, but can you just take a moment to tell me what the meaning of the origin is? Hit pause, write it down, hit play to check the word. So if I plug in a 0, I get 0 out. So sorry about the darkness, it'll adjust itself soon. So if I plug in a 0, f of 0 gives me 0, right? If no t-shirts are sold, Marilyn doesn't make any money. We kind of already said that earlier, but we're just being more specific today. So what I would like you to do is I would like you to actually write a function, All right, write a function, E of t, to model Marilyn's potential earnings given the number of t-shirts she sells. Keep in mind, you've already found your y-intercept and you've already found your slope. Go ahead, see if you can write an equation for this. Hit pause to write it out, hit play when you're ready to check your work. So we want to use E of t. We're not using an x, we're using an E for t, pardon me, t for t-shirts, and we're using E for earnings, so we're calling it E of t instead of x and y. We said that, so I'm using a t, not an x. We said our slope, we found that earlier, right? $15 per t-shirt. So we said our slope was 15. Our y-intercept, we can see, is 0. Oh, so it looks like my function is E of t equals 15t. Good job, us. Yay. So what does E of t represent in terms of the function and the graph, right? I know t is my input, E of t is my output. So what do they represent here on the graph? Go ahead and hit pause, jot down your thoughts, hit play to keep going. They're doing stuff outside in the classroom. I'm sure you can hear it. So in terms of the function, T is the number of t-shirts, right? We talked about that. T is the number of t-shirts, and E of t represents the amount of earnings in dollars, right? As far as our graph goes, it's a point, isn't it? Right? E of t represents the number of shirts sold and the money earned from that amount of shirt. It's a point on our graph. So with this in mind, and armed with your lovely function, E of t equals 15t, I have a couple of these for you to do. So you've already said E of t equals 15t. I'm just writing it at the top so I can mark it, see it. I would like you to evaluate each of these. You've got A, B, C, you got a couple of these, and not only do I want you to evaluate it, plug in a 2, plug in whatever, and see what you get. Can you tell me what it means in terms of our scenario, equation, graph, all that good stuff? Go ahead and hit pause, work it out, tell me what it means, and then hit play when you're ready to check it. So E of 2 means that instead of a t, I'm going to plug in 2. So E of 2 means 15 times 2, which is 30. So in terms of the situation, I have a point on my graph at 230, right? My input is 2, my output is 30, so this means there's a point on my graph of 230 that should be on that line. But more importantly, it means that if 2 t-shirts are sold, Marilyn earns $30. So how'd you do with B? How'd you do with the next one? Well, I plugged in a 5. 15 times 5 is, of course, 75. So this is the point on the graph that it represents, 575. But it means that if 5 t-shirts are sold, Marilyn earns $75. Ooh, wait, this one's weird. 2.75. Well, I went ahead and I plugged it in, right? 15 times 2.75. I totally used my trusty calculator because I was not going to do that in my head. And 15 times 2.75 is 41.25. Now, the only thing is, while that is a point on the graph, it doesn't make sense in the situation. Remember, our input was the number of t-shirts. You either sell a t-shirt or you don't sell a t-shirt. There's no like 0.75 t-shirts, like where you just sell them the shirt with like a chunk cut off of it. I don't know. So while this point makes sense on the function, it doesn't make sense in the situation because Marilyn can't sell 2.75 t-shirts, right? I mean, that's weird. Now, Marilyn does have a goal, right? And oftentimes when people go to these festivals, these farmers markets, like they gotta pay for the booth, there's costs that have to be covered. And so they usually have a goal of how much money they wanna earn. So Marilyn has a goal to earn $100 at the festival. So let's consider how to determine the number of t-shirts she needs to meet her goal. So to determine the number of t-shirt sales it takes to earn $100 using the function E of t equals 15t, that $100 gets substituted in for E of t. So instead of E of t, that's where my $100 are going to go. Because that's our earnings, right? We said E was our earnings. She wants to earn $100. So fine, I set it up as 100 equals 15t. We divide by 15 on both sides. I grab a calculator because that's what it's there for. 100 divided by 15 is 6.67. But you remember what T stands for, right? Can you interpret what that means, T equals 6.67? Go ahead and hit pause. Tell me what it means that we got T equals 6.67, and then hit play to keep the discussion going. So this means that to earn $100, 6.67 t-shirts must be sold. But again, we don't have 6.67 t-shirts. You sell a t-shirt or you don't. There's no 0.67 of a t-shirt. So we don't want to sell 6 t-shirts because she wouldn't be enough to make her $100. So that means to earn at least $100, Marilyn is going to have to sell 7 t-shirts. And real quick, why did we substitute 100 for E of T? Why did we substitute for E of T instead of for T? Hit pause, write that down, hit play to keep the discussion going. Remember that E stood for the earnings, and she wanted to earn $100. So E of T represents the dollars earned based on T, the number of t-shirts sold. So because $100 is the dollars to be earned, that's why it's replacing her E. Now, not only could we use the equation, which we did, we used the equation to determine the number of t-shirts that Marilyn needs to sell to earn $100. Do you realize you could have used the graph to determine that as well? True story. You could have used the graph. So if we take the graph, and sorry this is so small, I would go to, now remember E was our y-axis, so I would go to 100 on my y-axis and draw a line straight across. I'd see where it intersects, and I'd be like, okay, well, come on down. How many t-shirts is that? So to determine the number of t-shirts it takes, t-shirt sales it takes to earn $100 on the graph, you just need to determine the intersection of the two lines of that 100 when that 100 equals 15t. We wrote that down as an equation, but you can say, okay, here's 100. When does it hit my 15t? Oop, it hits right there. And then you can see this is your y-coordinate, this is your x-coordinate, and that's our point. That's the point, 6.67, 100. So again, in terms of the graph, Marilyn needs to sell 6.67 t-shirts to earn $100. In terms of the scenario, though, we know that means she needs to sell 7 t-shirts because, again, she can't sell part of a t-shirt. That's weird. So looking at how we can use the equation to solve these and the graph to solve these, what are the limitations of using each one to answer the questions about the number of t-shirts sold or the amount of money you earned? Why are there limitations on the equation? Why are there limitations on the graph? Go ahead and hit pause, jot down your thoughts, hit play when you're ready to keep going. So as far as the equation goes, I generally like using the equation, but sometimes an equation provides an answer that doesn't make sense in the context, right? Like we couldn't get even 6.67. We're not going to sell 0.67 of a t-shirt. So sometimes the equation does that, and the answer has to be rounded up or down to make actual sense of the answer, to really answer the question. We could sell 6 t-shirts or we could sell 7 t-shirts, but I can't sell 6.67 of a t-shirt. So the equation is great, but sometimes we do have to round our answers to make sure our answer actually makes sense and answers the question. The limitations of a graph, it's just that sometimes it's difficult to read an exact answer on a graph, right? I like the equation because it gives me very exact answers, but I do have to round sometimes. The issue with my graph is sometimes it's hard to see the exact answer. Like that last graph we looked at, it was hard to tell it was exactly 6.67 on the graph. That's hard to see on the graph. So the graph is cool, but just sometimes it's hard to get an exact answer off of it. As always, guys, I hope you found this helpful, and I hope you found this useful. If you've got questions or concerns, please, please, please email me, or of course, come talk to me. See me during lunch, and see me during office hours. I'm around, and I'll see you guys soon. Bye.